McDonald once said this, that life is a creation, not a discovery. The idea we can grasp or choose from it is indeed very broad, yet we have to accept the thought that it is rightly factual. Every biotic proponent in these planets, worldwidely, needs the fundamental factors in order for it to be created, to live life. Like for example, it needs the exact environment and the proper biodiversity where it belongs to. Good day viewers, especially to the panel of judges, and of course to our co-author, Engineer Bacaro. I am King P. Barber, teaming up with my co-researchers, Kalichi De Reyes and Edison Marat for this project thesis titled Development of Dual-Powered Smart Hexagonal Pllanter for Fragraria X Ananasa. A dual-powered smart hexagonal planter for Fragraria X Ananassa is a smart planter that holds a miniature environment for a strawberry or a kitchen plant and any plant useful to grow on places where the actual environment is not suitable for the plant to grow. Researchers were going to develop a smart planter that features dual-powered mechanism, automation, and monitoring system for conducting cultivation experiments to realize indoor gardening that uses vacant spaces in urban places. The project aims to support and cultivate fresh strawberries here in Surigao City, also promotes and encourages people to engage to smart indoor gardening and plant cultivation with the help of this planter. The study uses developmental research for designing and making instructional programs for the project, power supply, local or solar power, Arduino, Wi-Fi modules, actuators, and sensors such as methane, soil temperature, light ambience work together to meet the parameters and requirements needed for the strawberry to support its growth inside the planter with less user interaction. This smart planter system will provide convenience and comfort to the user by sensing and controlling the parameters of the garden without their physical presence. Any Android-supported device can be used to install the Blink application software, which is for the smart gardening application. In times of power outage, a solar panel can be used as replacement that serve as a backup power of the planter. The general objectives of this study is to develop and implement a dual-powered smart hexagonal planter for Fragraria X and Ananassa, or strawberry. To specify these, the first one will be to design a dual-powered smart hexagonal planter using pre-established parameters. Second one, to implement system commissioning, testing, and troubleshooting of the project hassle-free, time-saving, trouble-saving, environmentally friendly, and easy-to-use type of planter. Third one, to evaluate the system's performance and acceptability using pre-established measurements. Then fourth, or the last one, to determine the financial feasibility of the project. Going back to the partial defense, which was held last semester or the first semester of this academic year 2019 and 2020, we proposed rather how or what will be the suggested projects to be made by our team. Then we proposed like a few, or like 4 projects. Then one of those will be this hexagonal planter for Fragraria X and Ananassa. So it came up with the original title, which is the Smart SPHERICAL Planter, but due to the absence of the material that is a bendable plastic or something like a fiber that's bendable to become round to achieve the spherical enclosure, we ended up with a hexagonal type of enclosure. The purpose of doing such a spherical at first is that to allow like a round space, so that the more it is round, especially with the rooftop, the more it will allow space for the environment to be enclosed. But now it's a hexagonal, so at least it's still considerable. But the very best option is the spherical one. So the next one is that we finalize it with the final plant, which is the strawberry or the Fragraria ex Ananassa. But then again, the original plant for this one will be the sayote or the Sichumijule rather. Since the Sichumijule or the sayote is rarely being cultivated here in the town or the central city, it was also part. It became part as the main plant for this project. But we ended up with the strawberry since strawberry is really hard to cultivate here due to its factors to be accomplished, especially the moisturization of the soil and the temperature to be maintained for it to be cultivated here in such hot climates. The first sensor to be measured in an on time or in uptime view or uptime deliberation of this is the moisture. So here it waters, then as you can see on the phone, it automatically increased the amount of moisture until it meets its maximum amount of moisturization that stops the watering of the hose. So we used here a 12 volts powered 12 volts what do you call that water pump system into a canal or like a systematized into a three-way hose so that it will deliver on three partitions of the planter. The second sensor will be the temperature. So as you can see here, the temperature is being set like in 18.25 something or like 18 degrees Celsius since it's the minimum temperature required for the plant. And as you can see here, it gradually like increase in some random times or some random moments since the fan we used here sometimes doesn't blow like or doesn't function or like it's a momentary fan type that has certain moments where it stops, then it continues back into its rotating rotating function process. And also the peltier used for this is the TC12706, which is a 6 amps 12 volts powered peltier or like a cooling piece, which means that it's not that all the time it cools. Sometimes it pauses the cooling process. That's why the temperature is like from 18 something to 20 above something. Just that temperature to be maintained is the more important here, like the most critical factor to be considered. The third major sensor to be explained is the methane sensor. So why methane sensor? Methane sensor has a crucial effect on the amount of bacteria that is existing inside the environment or particularly the soil itself. So strawberry plants are very vulnerable to fungus or some sort of like disease for plants because this is a sensitive plant and it really requires like critical care or consideration when it comes to the moisture, temperature, and methane. So if the methane quality of the air increases, there is a bigger possibility that fungus will occur in the leaves. First of all, it is the leaves because we really experienced that before in like the early stage of this one. So yeah, and then once the methane increases, the fixation of bacteria increases too, allowing it to produce molds and dark spots. Like that's the major disease of the strawberry leaves, which is making the strawberry plant dying slowly but surely. Then also, if the methane is being lessened, the acidity also of the plant also lessens. Like it's a variable that is depending on the amount of methane. Like they're equally parallel, so on. Then the last one will be the light ambient. So of course we need the light to maintain. This light we use here is like a lumen light or not so rush kind of light. Just like maintaining light for the chlorophyll amount or the like photosynthesis process continues even on the night. And we use lumen light since it is advised for us because we are using indoor or we are doing this in an indoor type section of indoor type of planting. And also once it is indoor it's not allowed to go out, so it has to receive the sufficient amount of light when it's under the sunlight during a cold weather. So that is the goal here. This is the sample final output of the application, which is a screen cap only since we can't determine whether the moisture is high or low or something like that, but it's just a sample video or sample screen record rather of the official application. This is the part where we have the installment of solar panel as an emergency supply for the system. So first we have the solar panel, which is placed outside. The next will be the converter, which is connected from the solar panel then directly to the battery, which will serve as a emergency storage. The battery can be kept on the compartment which is located on the first level of the planter. Of all that has been done with this project, like from the very beginning, from the partial defense to the fabrication and manufacturing and development of this project, also including the what you call the testing, or and aside from that there is this like survey for our project, like the examiners or like the surveyors will check the planter and also rate it depending on how the system works, if it acquired the standards to be met, something like that. So I'm gonna conclude this one here. So from the results obtained, it showed that the planter successfully cultivates the strawberry with its required parameters needed for it to, in order to support the growth inside the planter. So the indoor planting or the smart indoor planting has been achieved here. The objectives were implemented from its design, implementation of system, and evaluation. So there's the right term, evaluation of the system. First, conclusion. The design of dual-powered smart hexagonal planters attained its precise result based from the pre-established parameters in terms of moisture, temperature, light, and methane content after through testings and troubleshootings. Second one, the developed integrated design elements of dual-powered smart hexagonal planter encourages people living in the urban areas such as cities to engage themselves in indoor gardening by the use of the planter, which is this result is based on the survey questionnaires or the evaluation form thing. Third one, the implementation of this project is hassle-free, time-saving, labor-saving, environmental friendly, and easy to use type of planter. Yes, of course, because there's a smart app, which is the trend nowadays in Internet of Things to be exact. And also it is reasonable because you have this planter, you can apply it to some other plants. Also you can adjust the system based on what plants are you going to plant. Then also the user will have less interaction with the planter because it automates from watering, lighting, and air conditioner, and also it can be controlled using the phone via Wi-Fi module and its application. It makes the indoor gardening easier and at ease. Then the last one, based on the computed results in the financial feasibility, which is shown on the documents or the manuscript, it is required to sell 3 units for the researchers to gain back the capital or the fund we use or consume for this research. So we are required to sell 3. But then again, since we achieved this project successfully, I guess we can be qualified to submit, or we are valid to submit our prototype for this one. So there are a few recommendations that we would like to pinpoint on this one. So furthermore, the following recommendations are formulated as through the process that we went through. First one, when preparing for the material needed in the project, it is better to know the first specifications and qualifications of the materials or module if it fits the design of the project before purchasing online or in a nearby store to avoid spending large amount of money. So of course, we have to like avoid those kind of wasted expenses by just really specifying those materials or etc. that is being needed here. It is also better to always buy and order ahead of time to avoid out of stock. So yes, is as a student we really are sometimes cramming, but yeah, it's life. Lesson learned. Next one, the addition of camera that serves as surveillance and monitor of the growth of the plant inside the planter, and a memory card for the storage of the data. So this is actually my personal recommendation, since if the situation goes like if one will be away, like the owner of the planter will be away, they will keep like shots or still moments inside the environment. There is like an available what do you call that, sensor or no actuator for this one, and I checked it out. Like when we almost managed to like finish this in this end time before the COVID-19, we managed to like find something that is matching for this recommendation, but it's too late already because we already established the system and it's fixed. And if we will really pushing that kind of with the camera thing, it will be hard to program and it's new to us. We will be shifting from like Arduino something to a Raspberry Pi, since it really needs an hard code programming. And based on my experience, I have not tried Raspberry Pi programming thing, just my other classmates, since I'm ahead of them. Yeah, so that's one of the recommendations. Third one, Twitter, which is an automated type will replace the upper part of the planter that will serve as an automatic opening controlled by phone. So this is just one of the light suggestions or recommendations in case if there's a troubleshoot going on inside the planter. We will not be like having an interaction with that or the planter itself. Instead, it will automatically open, then we will be allowed to like enter inside without even touching the planter. It's like getting the plant itself, then the planter will automatically open and close it on its own. I guess that will be all. Thank you for watching our video, and this is our project. It's now finally concluded.